Hello, this is the fifth video presentation of our project, CNNECST, aiming to automate the implementation of convolutional neural network on FPGAs. Today we are going to briefly analyze the possibilities offered by the market to our product. CNNs are used in image recognition, so we identified 4 macro areas that can be interesting: surveillance, assisted guide, and in particular drones and automotive. Focusing on the global value of these markets, we selected the last two as the best ones: the drones market with a 5.2 billion USD for year value and the automotive market with a 2 trillion USD for year value. In these terms, the second one is clearly the biggest one, but to better understand the situation, we consider some other aspects. For a new product, it could be easier to get launched on a smaller market. Furthermore, the drones market had a growth rate around 32% in 2015, which is estimated to keep constant till 2020. While the automotive market, which is older and more stable, probably won't provide any significant increment in the next years. This consideration led us to identify the drones market as the best one for our product, and we also defined some of the major threats to its growth for the next years. One important weakness of those devices is the limited possibility to be remotely piloted from a fixed location, as well as the difficulties in being controlled by a manned ground vehicle. But probably the greatest limit is the poor autonomy. The problem origins from the strict low weight constraints, forcing the choice of small batteries which inevitably last less. The project we are working on can be seen as one possible solution for this limit. In fact, the reduction of power consumption for the image processing, which is one computational intensive task, could extend significantly the time of flight of the drone. We choose the FPGA solution, but is not the only one. The GPU and the CPU solution are the easiest to achieve in terms of development time. But on the other hand, the first one uses too much energy, worsening the problem, and the second one doesn't respect the real-time requirements. Another possible one is the ASIC solution, which provides high performance combined with low consumption. The FPGA, however, can be freely reconfigured as many times as are needed, while an ASIC is much more expensive to produce. In conclusion, our proposal is to develop an application that automate, simplify, and speed up the process to design and implement a CNN on hardware, providing an accessible open-source tool to develop a vision system on embedded devices such as drones. Thank you for your attention. Keep following us on Facebook and Twitter. Bye!